Hello, good day everyone. This is Group 7 video presentation. This topic is titled Probability Distribution, Correlation Analysis, and Geometric Thinking, with a theme of problem-solving skills and probability to geometry. And these are group objectives. To increase the ability and knowledge of all students regarding the use of parts and data measurement, which are probabilities and normal distribution, linear regression and correlation, and also Van Hout theory of geometric thinking, so that the problem related to statistics, probabilities, distributions, curves, and geometry can be easily solved by them through knowledge and ability so that they will not have difficulty with any problems, and so that they will always remember this especially in the future and they can use them in their work such as the problems that belong to the data management and geometric theory. Before we will proceed with the introductions, I will first show you the content, law of the topics, and entity, which is the conceptual framework. Introductions. Inference, control, and probability distribution becomes an important issue, since many current types of research are heavily dependent upon statistical data that must preserve the confidentiality of individuals' information. One of the statistical concepts that are most related to this type of correlation analysis, the two main advantages of correlation analysis are that it enables quick hypothesis testing and assists business in deciding which variables they wish to look into further. While geometric thinking, according to the Van Hout theory, these are different stages of thinking that range in age from roughly 5 years old to academic adults.
Standard normal distribution, or Gaussian distribution, is a normal distribution with a mean of 0 and a standard deviation of 1. I wonder what could have happened if the glass slipper that Cinderella left at the Prince's Palace fitted another woman's feet. What do you think?
I'm thinking the same too. I think he would have ended up marrying another woman.
Female shoe sales by size is normally distributed because the physical makeup of most women is almost the same. A normal distribution has the following properties. First, the mean, mode, and median are all equal. Second, the curve is symmetric at the center. Third, exactly half of the values are to the left of center and exactly half of the values are to the right. Fourth, the total area under the curve is 1. Let's take a look at this example. As you can see, this is a normal curve and the graph is kinda look like a bell-shaped curve. Since the normal distribution is a continuous distribution, the probability that x is greater than or less than a particular value can be found. Additionally, every normal curve conforms to the following rule. About 68% of the area under the curve falls within one standard deviation of the mean. About 95% of the area under the curve falls within 2 standard deviations of the mean. And about 99.7% of the area under the curve falls within 3 standard deviations of the mean. Collectively, these points are known as the empirical rule or the 68, 95, 99.7 rule. Clearly, given a normal distribution, most outcomes will be within 3 standard deviations of the mean.
Discrete probability functions are also known as probability mass functions and can assume a discrete number of values. Example, coin tosses and counts of events are discrete functions. These are discrete distribution because there are no in-between values. For example, you can have only heads or tails in a coin toss. Similarly, if you're counting the number of books that a library checks out per hour, you can count 21 or 22 books but nothing in between.
Hey Kyla! Can you help me with my mathematics assignment?
Sure, Eds, what is it?
My teacher told me that we need to research what continuous probability distribution is. Do you have any idea what it is?
Yes, of course. Okay, let me explain it to you.
Okay, Kayla, thanks.
Continuous probability distributions are also known as probability density functions. You know that you have a continuous distribution if the variable can assume an infinite number of values between any two values. Continuous variables are often measurements on a scale, such as height, weight, and temperature. Correlation refers to the statistical association between two variables. A correlation exists between two variables when one of them is related to the other in some way. A simple linear regression model is a mathematical equation that allows us to predict a response for a given predictor value. Linear regression can be computed using the equation y equals a plus bx, which is called the least square line or the simple regression line. where A equals the y-intercept, B equals the slope, X equals the predictor variable, and Y estimate of the mean value of the response variable for any value of predictor variable.
Good day, this is Mark John Room, and I am here to talk about correlation, nonlinear, and linear. First is correlation. Correlation refers to a statistical association between two variables. A correlation exists between two variables when one of them is related to the other in some way. For example, oh, I have a quiz tomorrow. Now let me just finish 2 more rounds of this game. Oh no, I failed my quiz. I need to study for the next quiz. Next is nonlinear. Nonlinear is a relationship when the points on a scatter plot follows a pattern but not a straight line. For example, inflating a balloon is one of an example of nonlinear. Next is linear. Linear is a relationship when the points on the scatter plot follows a somewhat straight line pattern. For example, I'm going to my friend's house. I will get there in 3 minutes by walking. Finally, I'm here at my friend's house. Tao po!
Linear regression is a linear approach for modeling the relationship between a scalar response and one or more exploratory variables.
Sir, can we use a linear regression in real life?
Yes, agricultural scientists use linear regression to measure the effect of fertilizer and water on crop yield. They might use a multiple linear regression model using the fertilizer and water as the predictor variable and the crop yield as the response variable. Geometric thinking is concerned with how people reason using the properties of geometric figures and spatial relationships.
I know that this book-shaped rectangle have 4 right angle corner and 4 straight sides. Square is type of a rectangle.
Level 0 visualization. At this level, they are recognized shapes by their whole appearance, but it's not exact properties. The shape of a door is a rectangle, and the shape of a birthday hat is triangle.
Today, in the personal video, I will be discussing the levels from 1 to 4. Level 1, analysis. Analysis is a detailed examination of anything complex in order to understand its nature or determine its essential features. Example.
Hello, sir.
Hi.
I have a question, sir.
Sure. What is it?
What is an example of analysis?
An example of analysis is a shape with 4 sides of equal length.
Level 2, abstraction. Pupils or students perceive relationship between properties and figures. Example.
An example of abstraction is a direct proof. Simple deductions can be followed, but proof is not understood.
Level 3, deduction. They are able to differentiate between necessary and sufficient conditions. Example.
An example of deduction is the formal deductions, is that proof can be written with understanding.
Level 4, rigor. Measures arrange student thinking and understanding so that it measures what all students know and can do. Example.
Example of rigor is non-Euclidean geometry.
What is non-Euclidean geometry?
Non-Euclidean geometry is the study of the surface, which are not flat, because the surface is curved. There are no straight lines in the traditional sense, but distance minimizing curves, known as geodesics, will play the role of the straight lines for these new geometries.
Thank you, sir.
Properties of levels. Fixed sequence order. Student cannot be at level n without having gone through level 6 to 1. Therefore, the students must go through the levels in order. 2. Adjacency. At each level, what was intrinsic in the preceding level becomes extrinsic in the current level. 2. Distinction. Each level has its own linguistic symbol and its own network relationship connecting those symbols. 4. Separation. 2 persons at different levels cannot understand each other. The teacher speaks a different language from the students who is at a lower level. 5. Attainment. The learning process leading to complete understanding at the next level has 5 phases. Information, guided orientation, explanation, pre-orientation, integration, which were approximately not strictly sequential.